Okay, so this discussion is about post-processing operations, or another way to think about this might be the question, can a trained monkey do your job? Now, maybe you've never wondered about this question, but the next question might sound more familiar, which is, why are you in a bachelor's degree program when all you need is an associate's degree program to be an x-ray tech? This chapter really gets to the heart of these questions, and so I'm excited to be talking to you about it. So here's my objectives. I'm going to be discussing the key impacts of computer image manipulation on image evaluation and patient dose. Then we'll evaluate the obstacles to a standardized exposure indicator, and as well as the hope that we can overcome those obstacles. We'll define some terminology related to user-defined post-processing operations, and then finally we'll discuss some evaluation for like critiquing a digital image. So the key impacts of digital imaging are that brightness and contrast cannot be attributed entirely to a radiographic technique. The computer is going to apply algorithms and all these operations that we've discussed up to this point to enhance both brightness and contrast of our image. And so what this means is that there's been a shift from setting optimal images, creating optimal images as the primary drive for why we need certification for radiographers, and that shift has now focused, I would say, primarily on minimizing patient and public radiation exposure. So that sounds easy enough, but the difficulty is that we don't have standardized exposure indicators. So if you're shooting images on like an AGFA machine, the numbers that it reports will be different than Fuji or Siemens or just about any other kind of machine you could be working with. So in general, those exposure indicators are based on a median pixel value, and the book talks to some depth about what's the difference between a mean and a median, so it's worth reviewing that. But this resulted in the American Association of Physics for Medicine proposing the deviation index, which can be used by all manufacturers as a way to standardize the EI. And I should say right off the bat that manufacturers are all in the process of adopting the deviation index on all new equipment, and they're even providing some means to retrofit older equipment, and there's even been some provisions that have come from the United States government to encourage the adoption of the standardized exposure indicator. But the question might be, well, why did we have this problem of all these different manufacturers using whatever willy-nilly from the beginning? And that's because there's 3 different approaches to constructing a scale for exposure indicators. We might have a logarithmic scale, so like Carestream or Kodak and AGFA both use a logarithmic scale in which the things trend upwards to some limit. A proportional scale would be more like a straight line, and then an inversely proportional scale, like what we use over in our lab, the Fuji system, would look something like that. And so we're fairly familiar from our lab work with the inversely proportional scale that Fuji uses, because we talk all the time about if the S number is high, then the image is actually underexposed, so a high S number means I need to increase my technique, and vice versa. If the S number is low, it means that I have potentially overexposed the image, and so I may need to decrease my technique. And one of the interesting things about the S number for both Fuji and Konica is it's tied not just to EI, but also to brightness control. So the initial number that it gives us is the actual exposure indicator number, but then if we use an ROI or in any way manipulate the image to change that, then it's solely indicative of brightness control. So we've already talked about some of the limitations to exposure indicators, which are things like skewing from any kind of pre-processing error, segmentation error, exposure field analysis errors or any of the many kind of histogram analysis errors like from a prosthesis or barium or things like that. So there's limitations hard baked into the exposure indicators that further complexify the problem of having a standardized EI or using this as a way to determine how well we're doing what we're supposed to be doing. So, I mean, the question at the end of the day, when we ask, well, can a trained monkey do my job? Really, I think one of the things that we're asking is, what the heck is an acceptable EI? Like, how do we know whether or not the image that we've got in this digital age is actually a good image? And so I would really encourage you to read closely pages 544 through 547. And one of the very first things that the arguments that the writer makes is that it's institution specific. And by that I mean that it's ultimately determined by managers and health physicists and the radiologists who are reading the images. They're going to make some determinations about what's acceptable and what's unacceptable. But we do have some general rules of thumb that are really, really important to know. Number one, underexposed images should not be repeated unless the physician finds the level of noise unacceptable. Unless that quantum noise, as determined by a physician, is unacceptable, we don't necessarily need to repeat an underexposed image. Conversely, an overexposed image should not be repeated either unless saturation has occurred. So these were two attitudes that came out of film, that if the image is overexposed or underexposed, it automatically needs to be repeated. That's simply not the case anymore in a digital age. And then another thing that I think maybe separates us from a trained monkey is that it's inappropriate to use the DI all the time. Like, there's certain instances in which the deviation index or any exposure indicator it may be misregistering, or it may not be giving us an accurate number. And so being able to evaluate images for that requires some thought and some critical analysis. So even if an image is within the target range of DI, the radiographic technique might not be appropriate. So, and some of the things that could result in that are stuff that we've talked about from the very first day, like poor collimation, body habitus, the presence of prosthetic devices, as we looked at with histogram analysis errors, and even gonadal shielding could potentially artificially change the exposure indicator. And then it should be stressed, this is an indicator, not a measure. And so thinking in that way, I think just shows just that what we're talking about in part is an aesthetic judgment that is informed by a lot of critical thought. So taking a step back from maybe that kind of heady discussion of exposure indicators and just and thinking now about just general terminology that we should all be familiar with, this is also fairly complicated. And this is yet another reason for why there needs to be continued, in-depth, rigorous study of this field. But some of the terms that are fairly common throughout the literature, we've talked quite a bit about some of these. Windowing, are all those post-processing operations that we can, as a user, define to change brightness and contrast levels. Smoothing and edge enhancement type things can be done with kernels or with filters that will help either enhance an image or smooth out rough edges. Dark masking, we've seen that quite a bit. In our lab, it automatically applies dark masking, and so as you're watching it process the CR image, a lot of times you see a quick flash of the entire exposure, and then we see that dark mask applied. Black bone techniques are more common in fluoroscopy, but this is when an image is inverted so that bone appears black and soft tissue appears white. This will also be operator defined. Any kind of resizing or image stitching, we've talked about that some, read some about that in the last chapter. And you can see with all the different potential terms that might result from some of this, the ART recognized the necessity for a glossary of standard definitions. And anytime you see someone really saying, let's define our terms, let's make sure that we're all clear on what we mean when we say, for example, windowing, that also means that there is a great deal of rigor and a great deal of thought that needs to be applied to the subject. So finally, in this final discussion of like why I think it is essential to consider furthering your studies as much as possible, whether that's a bachelor's degree, or considering a master's degree, or moving into other areas of study like CT or MRI, comes down to this critical thought process of like, how do I know that I have an optimal image on this machine for this patient at this specific time? And these are some great rules of thumb that he outlines towards the end of the chapter, and I just think that each one of them bears repeating. That pixel values within the anatomy of interest shouldn't be completely white or completely black. Now that seems kind of common sense, but most of these rules are fairly common sense, especially for where you're at in your studies. Contrast and grayscale should maximize visualization of anatomic detail. Related, we should have a maximum signal to noise ratio. We should have more signal than noise, and this is largely controlled by sufficient KVP. We should have maximum spatial resolution. And then we should work to minimize artifacts of any kind, especially as we've seen that the artifacts can contribute to histogram analysis errors. And then we should minimize distortion, including magnification, even digital magnification of the images. We should be trying to create the right image right from the beginning. So these are some of the things that I think about whenever students ask me, why do we need to get a bachelor's degree or what have you, is I think that each one of these aspects of digital imaging are fairly complicated, and each part of it leads to more complex issues for us to think about, and there's need for more continued study in this field. Thanks.